range. There are three basic sequence types: list, double, tuples, and range objects. Additional sequence types tailored for processing of binary data and text strings are described in dedicated sections. Common sequence operations. The operations in the following table are supported by most sequence types, both mutable and immutable. The collections.abc.sequence ABC is provided to make it easier to correctly implement these operations on custom sequence types. This table lists the sequence operations sorted in ascending priority. In the table, S and T are sequences of the same type, N, I, J, and K are integers, and X is an arbitrary object that meets any type and value restrictions imposed by S. The in and not in operations have the same priorities as the comparison operations. The plus, concatenation, and star repetition operations have the same priority as the corresponding numeric operations. Operation result notes: X in S true if an item of S is equal to X, else false. X not in S false if an item of S is equal to X, else true. S plus T, the concatenation of S and T. S multiply S repeat n times or n repeat S, equivalent to adding S to itself n times. S I, ith item of S, origin 0. S I J, slice of S from I to J. S I J K, slice of S from I J with step K. Length S, length of S, mean S, smallest item of S, max S, largest item of S. S dot index X, comma I, comma J, index of the first occurrence of X in S at or after index I and before index J. S dot count X, total number of occurrences of X in S. Sequences of the same type also support comparisons. In particular, tuples and lists are compared lexicographically by comparing corresponding elements. This means that to compare equal, every element must compare equal, and two sequences must be of the same type and have the same length. For full details, see comparisons in the language reference. Forward and reversed iterators over mutable sequences access values using an index. That index will continue to march forward or backward even if the underlying sequence is mutated. The iterator terminates only when an index error or a stop iteration is encountered or when the index drops below 0. Notes: while the in and not in operations are used only for simple containment testing in the general case, some specialized sequences such as str, bytes, and byte array also use them for subsequence testing. GG in X. Printf. GG in X is true. Values of n less than 0 are treated as 0, which yields an empty sequence of the same type as S. Note that items in the sequence S are not copied, they are referenced multiple times. This often haunts new Python programmers. Consider list 3 times. list is equal to empty string 3 times, then print lists, print lists will print what? Okay, 1 2 3, and then list of 0 dot append 3, 0 dot append 3, and then print list. It will print 333, list of 0. This is very tricky, right? This is list and empty list. This is list and this is within it empty list. This is 0th element, right? 3 times multiplied by 3. So this will be multiplied by 3. What will be the output of this? Let's see. 2 empty items. Let's comment it out for now. Let's print list 1 2 3 1 2 3, and let's print out 0th element, list 0. Okay, let's check length of list. Length of list lists. Let's see what it prints. 6, right? And then let me print 0th element, list of 0. See what it prints. 1 bracket, right? And now let's do 0 append 3 and print list. Let's print list of 2 is 1, and what it prints, let's see. Okay, what about print list of 2 3? Okay, that's correct. And size of list is len list should be 6. Okay, so these were list operations. And then what has happened is that list empty list is a one element list containing an empty list. So all three elements of this are references to the single empty list. Modifying any of the elements of list modifies this single list. You can create a list of different lists this way. List is equal to for example, list is equal to empty for I in range 3. Print list. okay, 3. Empty. For I in range, print, I mean, print this for I in range 3. Okay. List dot append 3. Now list dot append 3, print lists, list of 0, 3. List dot 1, 5. And list dot 2, 10. And print lists like that. And if try to add list dot 3, it will throw an error. Correct. Further explanation is available in the FAQ entry. How do I create a multi-dimensional list? 3. If I or j is negative, the index is relative to the end of sequence, as length s plus I or length s plus j is substituted, but not that minus 0 is still 0. The slice of S from I to J is defined as the sequence of items with index k such that I less than equal to k less than equal to j less than j. If I or j is greater than length s, use length s. If I is omitted or none, use 0. If j is omitted or none, use length of s. If I is greater than or equal to j, the slice is empty. The slice of S from I to J with step K is defined as the sequence of items with index x is equal to I plus n into k such that 0 less than equal to n less than j minus I divided by k. In other words, the indices are I plus k, I plus 2 into k, I plus 3 into k, and so on, stopping when j is reached but never including j. When k is positive, I and j are reduced to length s. If they are greater when greater. When k is negative, I and j are reduced to length s minus 1. If they are greater, if I or j are omitted or none, they become AND values, which ANDs depends on the sign of k. Not k cannot be 0. If k is none, it is treated like 1. Concatenating immutable sequences always results in a new object. This means that the building up a sequence by repeated concatenation will have a quadratic runtime cost in the total sequence length. To get a linear runtime cost, you must switch to one of the alternatives below. If concatenating string objects, you can build a list and use str.join at the end, or else write to an io.stringio instance and retrieve its value when complete. If concatenating bytes objects, you can similarly use bytes.join or io.bytesio, or you can do in-place concatenation with a byte array object. Byte array objects are mutable and have an efficient over-allocation mechanism. If concatenating tuple objects, extend a list instead. For other types, investigate the relevant class documentation. Some sequence types such as range only support item sequences that follow specific patterns and hence don't support sequence concatenation or repetition. Index raises value error when x is not found in S. Not all implementations support passing the additional arguments I and j. These arguments allow efficient searching of subsections of the sequence. Passing the extra argument is roughly equivalent to using S of Sij dot index x only without copying any data, and with the returned index being relative to the start of the sequence rather than the start of the slice. Thank you.